All right, up and running. So this video is going to be, I'm going to do the problems on the worksheet that I'm going to hand out tomorrow. And we'll probably spend a couple of days on this. There's a lot of material that I'm throwing at you, a lot of new stuff. And for those of you who took Algebra 1 already, it seems like some of you have. It's not new, but it seems to be new. Anyway, I'm going to do 3 problems like the first problem. And later in the worksheet, there are similar questions, and you have a go at it in class. But starting with writing the equation of a line, which is the easiest of all the algorithms that we are going to perform conversion, converting inputs to outputs. And linear is the least complicated. It's something to the first power, which we basically ignore. So how do I get rid of -9? I want to add 9. If I add 9 to this number, it's gone. And if I want the y value of 17 to appear, I write it. And not rocket science. And so there we can see a change of 10. But a change of 10, I have to convert to a change of -17. So how do I take the number 10 and turn it into -17? Well, I think I have to find the multiplier, which is what slope is. It's a ratio of change. And I think multiplication on the left becomes division on the right. All right, so if you put the change in y, which is really y2 minus y1, but it's easier to say, how do you get from here to here? You go down 17. All right. And how do you get from here to here? You go up 10. Then I think this probably continues. That probably works. And if I go up another 10, that probably works as well. Let's see if that really works. Let's put 21 in. 21 plus 9 is 30. Oh, you know what? 10 goes into 30 3 times. And if I go down 17 3 times, I go down once, I go down twice, I go down 3 times. By God, I think I'm at -34. So 10 goes into 30 3 times. Let me get an eraser here. 3 times -17 is -51. -51 plus 17 is the opposite of 51 minus 17. If I take 10 away, I'm at 41. If I take another 7 away, I'm at 34. And it's minus. By God, it works. So now I'll do 3 more or 2 more random ones. And later on the sheet, you get to try this process for yourself. So 2 more. I'll just put some numbers in. Let's see. How about we put in 2 gets us 20, and a 5 gets us 33. All right, so you write the equation of a line, pause the video, try it yourself. I'm just going to write it. This x minus 2 plus 20 connects this number to that number. Change the 3. I don't want to change the 3. 20 plus 3 is not 33. How do I get from 20 to 33? 13. What are some other numbers? Well, I'm going up by 3, up by 13. What's that? 46. 846 should work. Put an 8 in. Put a 46 in. Check to make sure it works. Okay, this is 6. 3 goes into 6 twice. So I'm adding 26 to 20. I'm adding 13 once. I'm adding 13 twice. And 26 plus 20 is 46. All right, let's try one more. Let's try -5. Let's go to 11. And let's go to 1. And let's go to odd number 19, 20. That's good enough. For our purposes, -5 becomes +5. All right, so it's always the opposite, right? And then we want 11, so we got the marker, we write it. What's the change on this side? 6. I don't want 6 units of change. 11 to 29 is 9. And I don't care at this stage if you reduce that. Obviously, it's 3/2, right? Common factor of 3. I suppose I should put it that way. Well, it looks like to get 120, 120 is down here somewhere. I should be able to get there by going up by 2, -3, -1. Well, there's 1, yep. And I should get there by going up by 3, 14, 17. Yeah, 120 is on that pattern. Now we look at quadratics. It's a very similar process. Right? We're making the numbers work. Okay, I handed out a sheet. I wish I had that with me now about the squaring process, but we'll have that in class. Squaring process, well, you can fast forward videos, right? We got 9 from -3, -3. We got 4 units from -2, -2. We got 1 unit coming from -1 times -1, 0, which is the most important square, no area. It's unique. 0 gets us 0, right? And that's the smallest area we can get from squaring. And then we got our 1, our 4, and our 9. All right, from 1, 2, 3. All right, so we're looking at the first problem is 230 to 1019. 230 to 1019. I think that's what I said. Yep. All right, so first thing I see is I've got a maximum, right? Because this is the vertex. So at 2, 30, I'm on a graph and I'm going down, not up. Now 10, let's put 10 here. Let's put 2 here. If I look at quadratic change, I'm going over 8 units. And if I square that, I should be going up 64 units. That's what should be happening. Because when I write x minus 2 squared, I'm measuring change, square change, not just change, which is linear. I'm looking at square change, numeric. And I put a 2 in, I'm getting a 0, right? And 0 squared, when I put a 2 in, that's going to be the vertex, right? Because this is unique. All right, and if I drop a 10 in, then I really get 64 plus 30, and you know what? That does not take me to 19. So this 64 has to be taken out of the equation. And how do I get from 30 to 19? I go down 11. That's what's going on conceptually. That takes me to 19, and that's the graph. All right. Now, is that all I asked you to do with that? Yes, it's all I asked you to do. So let's try another one. And I'll try to get you something that this time gives us a little easier situation. So let's look at 5, 7, and let's go to, and that's your vertex. So can you write part of the equation right now? Pause the video. I hope you're writing x minus 5 squared plus 7 will give us our area statements, which we call y in this case. And I'm going to go to, let's see, let me go 8, 9, 18. So 25, that's going to be user-friendly number here. So 5, 7 to 825. So let's cut shape up because I'm going up. And here's 5, 7 and 825. Well, 8, the number 8 means that I've changed linearly by 3, but the quadratic change is 9 units. Right? So I should be going up 9 units. What do I want to go up? I want to go up 18 units. Well, I think I got to double this. Well, let's see what happens. 8 minus 5 squared is 9. 9 plus 7 is not 25. We get rid of the 9. How do I get from 7 to 25? I go up 18. Well, there's your 2. X minus 5 squared plus 7 equals y. Here's the equation. Whose vertex is 5, 7. Also passes through this coordinate. Okay, let's try another one. Then we'll be doing this every day. Every day for the rest of the semester.
You'll be doing this problem, and I hope at some point you connect with it. But remember, rule of 4. This is day 3. Rule of 4. Actually, I'm not sure that that's even day 3 for this problem. I think I might have introduced that on day 2. So it might be only your second day of doing this.
Okay, so let's look at how about a vertex of -2, 9. And let's go to 5. Let's go to 20. Okay, so what do I see? I see if this is the vertex, then that number acts like a 0. It needs to act like a 0. So I've got x plus 2 squared plus 9. That nails the vertex. I put a 5 in, I get 49 units of change. I don't think that's 49 units of change. Nope. I don't think it's 49. I think that's just 11 units of change. And there is our calculation. This vertex is -2, 9, but also passes through the point 520. Now we're looking at some logs. All right. Some logarithms. Log base 3. No, I think it's log base 9 to get 3. So really asking the question, 9, well, let me put that question here. 9 to what exponent gets us a 3? Well, can't talk about rules of exponents unless the bases are the same. And I think there's a way of writing the number 9. I think it's 3 squared. So 3 squared to the x equals 3, and there's an exponent here that we don't have to write, so 1. Sure looks like this rule has to give me that number. And the rule here is multiplication. I hope you got that from your pre-algebra classes. Right? And so 2 times what exponent equals 1? I guess it's a half. Well, let's see if you recognize what that operation is. That's a root. That's just another way of writing that. And we write roots this way because, remember, computers came on the scene, I think, in the 1930s and 40s, and Turing. Right? Machines work better with numbers than with symbols like that. So that is the same thing as a square root. And the square root of 9 is 3. So that's the exponent you need on top of the 9 to get a 3. And every time we say that, gives your neuronal activity a chance to connect. And we need those neurons to connect. So we got to keep talking about it. Like log base 4 of 1 over 64. Log base 4 of 1 over 64. Well, 64 could have been written as 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So I can put this in the same base. Okay, so I know I got an exponent of 3. The question is, it's in the denominator. We've talked about that already. So that's the exponent I put on top of 4 to create that. Next one. You're pausing the video each time, trying them on your own. Trying them in class, remembering that you try them in class, hopefully. So here's the exponents that we have to learn each command. And I think we just looked at that command. That's a square root. What's the square root of a fourth? It's a half. 1/2 times 1/2 is 1/4. So I could have done that. And if I did the square root, I'm here. I could cube that. I could do 1/2 times 1/2 times 1/2. That's 1/8. Rules of fractions. And then I could do the negative sign, which is take a reciprocal. So this answer is 8. And I'm flipping the fraction, I'm taking the square root, and I'm cubing. Now, what's the easiest way to do this? Because order doesn't matter. If I looked at this, first thing I'd do is the reciprocation. So 4, I've used this now, so that means that that is still left for me to work with. And rather than cube 4, I think I'd take the square root next. The square root of 4 is 2, and 2 cubed is 8.
So the order you do things in matters in math, and we're looking for the easiest way to do every problem. And the only way we're going to learn, the easiest way to do every problem is to do lots of problems. Like binomial squaring. And I wrote key moment because there is a key moment here. And the key moment is after you do a problem, I'd like you to write the answer right underneath it because lots of times you can see patterns that allow you to do something more quickly and easily. All right, so you'll probably taught 2x minus 5 times 2x minus 5. I never do that anymore. I know 2x times 2x is 4x squared. So I just square that first term. And then I look at the inside out, right? Foiling, which is somebody mentioned foiling to you. There's a minus 10x there. There's another minus 10x there. If I add those, I get minus 20x. Well, I can see the minus 10 right here. And I know I got two of them. So I just product it. What's the product of minus 5 times 2x? I find that in my head and I say, oh, that's minus 10x. Then I got two of them. And minus 5 times minus 5 is 25. So I see positive squares in the beginning, positive squares at the end, and doubling the product. All right. So let's do three of those. Let's look at 4x plus 3. Let's square that. And you can do it on the side. Go ahead, do it on the side. And see if you get the following answer. Remember, you're pausing the video. 16x squared plus 24x plus. Go ahead and do it out. That's what you should get. I'm looking at the product. That's the hard part here. And if you put in the effort to learn this, then you can do these effortlessly. So there's 12x. I got to double it. Positives at the beginning and at the end. Just squaring these numbers. One last try. And then we'll up the difficulty of the binomial squaring. Let's do 3x minus 7. Let's square that. Feel free. Go ahead. But if you want to take the shortcut, pause the video, try it. You should get 9x squared minus 42x plus 49. Let's check that, see if it's true. Let's put a 2 in here. 2 times 3 is 6. 6 minus 7 is negative 1. Negative 1 squared is positive 1 if I let x equal 2. If I put a 2 in here and it doesn't come in as positive 1, then hey, we're done for the semester. I could have made a careless error. Right, let's put a 2 in. 2 squared, always square before you multiply. 4 times 9 is 36. 2 times negative 42 is negative 84. And 49. Let me add 36 and 49. There's a 5, there's a 1, there's an 8. What is 85 minus 84? Whoa, it worked for a random number. It's not a formal proof. It's good enough for me. I think I can write this that way. And I think I can write this that way. And one thing we want to learn in this class is a lot of mathematics is, geez, I don't understand how to do this problem. Can I write it a different way? Key moment. All right. So now let's up the level of difficulty a little bit. Let's do 5a to the 3 minus 2y to the 4, and let's square that. Well, if I do 5a to the 3, and I multiply it times 5a to the 3, I know that I can rearrange that to be 5 times 5, a to the 3 times a to the 3. And if you take your time, that's 25a to the 6. You can plug some numbers in, prove it to yourself, maybe plug the number 2 in. It's going to come out to that. And I know minus 5 times minus 2 times 5 is minus 10. So I'm going to double that. And then I have the product a3y4, which is just some number. It's just some number. And I can't do anything with rules of exponents. I don't have the same base. Nothing I can do there. And if I square a negative, I get a positive. If I square the number 2, I get 4. And if I square y to the 4, I get y to the 8. We'll do 2 more of those. And if you put some numbers in for a and y, you can prove to yourself
That's true. So let's look at, how about 4x5 plus 2y7. Let's square that. Pause the video. You're welcome to do this again. I'm taking the shortcut. 16x10 plus 16, 2 times 4 is 8. I'm doubling it. x5, y7. Squaring a 2 gets me positive 4. Y to the 7 squared is y to the 14. One last one. Let's look at, how about 9x minus 7y10. Let's square that. 81x squared minus 63 doubled is minus 126, I believe. 68. And that's xy10. Multiplying negative 7 times negative 7 is positive 49. Y to the 20.
Maybe 4 days of practicing that, day 4. Maybe you got it down pat. We'll find out. All right, we're going to sketch.
And then writing in graphic form, which is very different than writing in graphic form and sketching. Why?
Because it's easier to do it that way.
6x squared
Minus
12x plus 7.
So much I got to say about this, but we got to start the conversation somewhere. So let's do the easiest stuff first.
X squared, we know that x squared gives us that up 1, up 4, up 9 trajectory.
We got the board in class
To show that. And the same thing, there's symmetry up 1, up 4, up 9 on the decreasing side. But a positive x squared is a cup shape up. So that's all you have to do. Recognize it's positive, it's cup shape up. And then we got to nail the vertex. How do we nail the vertex?
Well, hopefully I've explained to you in class. I'm not going to do it again here about minus b over 2a.
So minus b is positive 12. 2 times 6 is positive 12. So the key number here is a 1. And if I drop a 1 in, we get 6 minus 12 plus 7. That's what I get when I find the y of 1. That x is 1. Plug it in. That's what you do with x's. And boy, oh boy, there does seem to be a pattern here that I notice. Must be a coincidence. So this is minus 6 plus 7, which is also 1. Oh, I don't like the same number appearing anywhere early on in the course, but it happened 2 years, so we got to live with it. And I know where 0 is. 0 is to the left of the next value. So I know I'm over here. And if I plug in a 0, I get another value pretty quickly. That's all you need is vertex and another point, which means that a 2 also gets us 7. And we can put a 2 in and see a 7 come out. 24 minus 24. Oh boy. Plus 7. Oh yeah. No, sure seems to work. It's not the best example of the quadratic change, but it's what we got. So how do I get from 1 to 7? If I go over 1 and square it, I should have gone up 1, but I really went from 1 to 7, which is a change of 6. So the ratio of rise over run squared, which is what that A term is, rise over run squared as measured from the vertex, happens to be 6. I'll take another couple of problems that are maybe a little easier to work with. And I'll also get the roots for you, just for the heck of it, but those roots are imaginary. So let's look at 2x squared minus 20x plus 3. So again, positive. I didn't write that last one in graphic form. I'll write this in graphic form. You're pausing the video. Do you remember from the video how you get that x value? Minus b over 2a, which is 20 over 4. So we have an x value of 5. And if I put 5 in, 5 squared is 25 times 2 is 50. Minus 100 plus 3. Oh, it must be a coincidence. 2 to 1 opposite. So that gives me minus 50 plus 3, which is minus 47. Now, why don't I find y-intercept? Because then I've got the graph.
How do I find the y-intercept of any function? I plug 0 in for x. Right? You got Descartes' coordinate system for your pre-algebra. You should have been plotting numbers on that. Prerequisite for being in this course. And if you didn't learn it, you can learn it here. All right, so let's say that's 0, 1. Let's say this is 0, 5. Let's say this is 0, -7. What do you notice as a pattern? The y-intercepts all have x equals 0. If you plug a 0 in, you get 3. 0 is to the left of 5. Okay. So if I went over 5 units to 0 and I squared it, I should get 25 units of change. But how far is it from -47 to 3? It's actually 50 units of change. How do I turn 25 units of change into the 50 that I need? By doubling. So what was the graphing form? Take the 2, make a 0 out of the 5, subtract 47. Okay. Now I've done some binomial squaring. You should be much quicker at that. What's x minus 5 squared? X squared minus 10x plus 25. What do I get if I double that? Subtract 47. 2x squared. Oh, I got that one. 2 times minus 20x. Oops, I got that one. 2 times 25 is 50. 50 minus 47 is, oh, I got that one. Wow. I also have the roots here, by the way. I mean, roots are when something equals 0. So I got a 0 there and a 0 there. Just for the record, the roots happen to be, if I solve that, the roots just happen to be, I'm measuring from 5 in a positive and negative direction. I've got to go up. Minus 47 is 0. I got to go up 47 units to get there. And if I got a multiplication of 2, then there's a division of 2. There's your roots. Not that they mean anything to you. No. But you can see how they work if you plug them in. So let me plug them in, because we got to start the conversation. All right, so let's do the math. 5 minus 5 cancels. When you square a positive or a negative, you get a positive. When you square the square root of 47 over 2, you get 47 over 2. What happens to the 2s? 2 divided by 2 cancels. And what's 47 minus 47? Yep. Find our roots pretty quickly. Let's do one more. This time we'll do a negative. And remember rule of 4, I don't expect you to know how to do this yet until you get a good week of practice. And then I hope a bunch of you in the class can do it. For those of you who can do it, you help those who can't. And then maybe in another few days, the folks who can't can do it. And then your SAT scores are going up and you're happy because you're getting something right. So don't panic right now. I'm overloading you. I know the feeling of being overloaded. I had a Spanish class that was taught this way. I was ready to bail after 4 days. And then I realized, oh yeah, got to start the conversations and keep them going. All right, so let's look at minus 2, x squared. How about we do minus 12x plus 5? And let's sketch it. Looks like it's cup shaped down because it's negative. Minus b, 12 over 2a, negative 4, gives me negative 3 as an x value, which means my y-intercept is to the right of that, because on a number line, 0 is to the right of negative 3. Always look at that, figure out where your y-intercept is, and I can see my y-intercept is 5. Right, so I'm one step away, one little step away from having this graphed, having some ownership of it. I know the graphing form right now is 2 minus 2 times x plus 3 squared. I know I've got that much of it. I just don't know this y value. That's all. And I got to plug that y value right there. How do I find it? What do you do with x values? You use them. So let's plug it in. There's some real shortcuts here, but you know, you're just learning this. So let's plug it in. Minus 3 squared. 9 times negative 2 minus 18. Minus 3 times positive 12. Oh, there's that 2 to 1. I wonder what's going. Must be a coincidence. Plus 5. I add those together, I get half of this. 18 plus 5 is 23. I now know the y value
that goes with -3 is 3. And how do you get from 23 to 5? You actually go down 18. And if you square the change here, change is 3 units, and if you square it, you get 9 units of change. Oh yeah, that confirms
Our multiplier gets the job done.
what are the roots? Well, the roots are when y equals 0. Right? So how do I get there? Well, I know I'm starting from -3 and I got to move this way and that way to get an x and an x that give me these roots. Okay, so it's real easy to say my roots come from -3 plus or minus some quantity. And I got to do what? Got to go from 23 to 0. Well, I guess I got to go down 23 units. But I'm multiplying by -2. And the negative divided by a negative, positive. I got to undo squaring.
Those are your roots. I still don't think it means anything to you. But we started the conversation.
All right. Yes, this is going to be work. And yes, you can see these questions for the rest of the semester so that you bring it into your next class.
And maybe I can start teaching calculus again. All right, so where are we at? We're at square roots, 1, 2, 15, 11.
I wish I had. Let's just do the 0, the 1, the 4, and the 9. Okay, so what's the square root of 0? Square root of 0 is 0. What happens if I have an area of 1? What's the square root of 1? Well, that's 1. I just gone up 1 unit. I'm going to put a y value. That's a y value of 1. And then what's the square root of 4? 2. Oh, well, 4. Well, that's 1 unit. Then I got to have 4 of those. 2, 3, 4. I'm out here. And the square root of 4 means I'm only going up 1 unit. 1 more unit of change, which puts me about here, the number 2, right? So 1 unit of area gives me a side length of a square, side of the square, right? 1 unit of area, the side is 1. 4 units of area, let's put the numbers in. 4 units of area, 2. Maybe you can anticipate what the next number is. That's for, 9 is rounding. I'll say that's about 9 units. Hope I'm close. And I've done what? I'm 3. Well, I'm seeing this kind of shape. And the most important square root is the square root of 0. All right, so let's say we have an end point.
And our end point is, let me see, 1, 2,
15, 11. 1, 2, 15, 11. And I know the most important square root, side of the square, it comes from the area, and I want no area. So I'm going to say x minus 1, because I want that number. And I know that gives me this, because 0 times 0 is 0. But I want 2. Get the marker. Here we go. I can't use numbers less than 1 because I'm not going to take square roots of negatives. There's a reason for that. I'm not going to discuss it here. We're just going to deal with square roots, which are really distances, and distances are for the most part positive. But the smallest distance you can travel is 0. And so that gets us started. And I put a 15 in. If I put a 15 in here, you got to see that you get the square root of 14 as a number.
most of you are just saying 15 minus 1 is 14, and you're ignoring that extra operation. And the world has ignored that for centuries. But it's true, and it's simple. So we're going to learn how to do it.
All right, is the square root of 14 plus 2 taking me to my second value, 11? And the answer to that is no. That number does not take me from here to here. What takes me from 2 to 11? 9 units of change. Now you put that in your calculator, and you're going to get that graph.
And it's easy to learn after about 4 days. Some of you already have it, I bet, now. Okay, some of you already had it on day 1.
Okay.
But you got to get familiar with these trajectories. why they are what they are, which comes from pictures. That's what's not in the textbooks anymore. But ancient mathematicians all worked with pictures.
All right. Boy, man, I'm random. All right, so now I gotta give you a couple more, see how you do. All right, let's try 2, 3 to 920. Now you pause the video and I hope you're right to follow. I hope you're right. X minus 2 plus 3. I hope you throw a 9 in and get the square root of 7 out of there. From 3 to 20 is 17. And if you plot that, 2, 3 over 2 up 3 maybe here. 920 might be out here. And I'm just going to show you what the trajectory would look like if you were on decimals, which is what we'll use for calculators in this class, because it's free. Saving a couple $100 without having a textbook here, we're going after all the fundamentals. And this isn't in the textbook, so we'll figure. All right, so let's look at, how about we look at 4, 7, and let's go to 19, comma, let's go to 1. Okay, well, first thing I see is 7 goes to 1. I'm going in the other direction. 4, 7, well, I can write x minus 4 plus 7. We can get myself a square root function that passes through the coordinate 4, 7. You can see that. Now, if I put a 19 in, I get the square root of 50. 19 minus 4 square root. I don't want the square root of 15 plus 7 to take me to 1. I just want to go down 6 units. And so there's your function. Put it in decimals, you got your graph. All right, I'm doing 10 problems here. Let's see, what number are we on now? I think I've done, did I do enough of those? I hope so. Okay, now we're just doing some logs. Log 8, you get 64. You pause the video and try it. I hope you say that's an exponent of 2. Why? Because 64 equals 8 squared. And when we're solving equations, logging base 8 becomes exponential base 8. Same way addition becomes subtraction, logs become exponents, exponents become logs. All right, let's try another one. Let's try log base 8 of 1 over 64. Well, I hope you still say 2, but it's in the denominator. Right? 1 over 64 is equal to 8 to the negative 2. Let's change some numbers here. Let's look at about 25 equals 5. We did that earlier. What do you see? I'm seeing a square root. I'm seeing that 5 is written as 25 to 1/2, which means the square root of 25. There's a little repetition. You might not have gotten it earlier in the video, but we just come back to it, give you a chance to forget a conversation. Then we have the conversation again. And the hardest one would be something like log base 8 gets us 4. That's a little more challenging. Why? Because they're not the same base. But I think I can make them the same base. I think 8 is 2 to the 3. And I think 4 is 2 squared. I think I can turn this 3 into a 2. Yeah, I think I can. I think I can turn 3 into a 2 by multiplying by 2/3. But let's see why I can do that. So this is asking the question, what exponent do I put on top of 2/3 so it becomes 2 squared? Well, the base is the same. So really, I'm looking at the rule of exponents here, which is 3. I'll call the exponent x equals 2. Well, I guess x equals 2/3. Now let's check it. Let's do 8, which is what this was to begin with. This was 4. Can you do this operation? Put it in front of you now. It's been a couple of days. Do you know what that means? I hope you're saying that's the cube root of 8. And I hope you know what that is. That's the number 2. And I hope you know if you square the number 2, you get 4. And I'm hoping the repetition's starting to kick in a little bit, that more of you are starting to get that right. That's my hope. So, do I do the others that are on the sheet? Yes, I'll do those real quick. So I also asked you, where the heck am I? Oh, I did them all except for this one. 64 to the minus 2/3. Right, so what are you going to do first? I hope you're going to do the cube root of 64. which is equal to 4. So I did that. It gives me this answer. And then I hope you're going to take 4 and you're going to do to the -2. And I hope you're going to do 4 squared first. 4 squared is 16. I would do that next. Right? So that would take care of that operation. And I hope you know what the minus is. The minus is a reciprocation. Right, so I'm doing that conceptually with you. You can clean it up on your paper, but you got to understand what you're looking at. So we just had that conversation. All right, we got 2 more. Solving right triangles. X is 4, Z is 7. So hopefully in class, we talked about putting something in standard position. So our X value is 4 and our Z value is 7. That looks about 4 to 7. So how do we do that problem? Well, let's look at 7 squared is 49. Let's look at 4 squared is 16. So what is this area? 49 minus 16, 39, 33. So what is this distance? Square root of 33. And that's how we're going to do Pythagoras. And that's how we're eventually going to start doing trigonometry, is understanding how to do this quickly and easily. So let me give you a couple more. I'll just change the x's and the y's. All right, let's say you go over an x distance and the y is 6. And how about we make this 8? All right, so what do we have? We got 6, 8. Well, 8 becomes 64. 6 becomes 36. 36 from 64 is 28. So I guess, is that right? 30? 64, tired brain here, minus 36. So I got to do this. 14, there's an 8, but yeah, 28. All right. And if that's 28, then this becomes the square root of 28, which we will learn to work with. And simplify, that becomes 2 root 7. Okay, big deal. Show you how to do that later. Let's try another one. And you see what you get. Let's find this y value. If we already did one with that, so let's find this z value. If we have, let's call that 5, let's call that 7. You go ahead, I'm seeing 25, I'm seeing 49, I'm seeing 59, 64. Really? I did that 74. It's 74, so therefore z is the square root of 74. And I guess that's a distance, isn't it? Yeah. What? Well, if I can get a change in x, I can get a change in x. I can get a change in y. Sure looks like I can find the distance between a couple of points. Nice to know. Oh, that's what the next problem is. The distance between -3, -9, and 5. -3, -9. Did I get that right? -3, positive. No, -3. Poor eyesight, you're terrible. Yeah, -3, -9. All right, so let's call this -3. Call that -3, -9. Let's call that -9 down here. That's how you plot. And then we're going to go to 5, 1. So if that's -3, I think 5's about here, 1's about there. Okay, so -3, -9 is here. I got to erase this now. I'm going to erase this. I'm going to erase this and call this 5. I think it'll be easier to see. But is there anything preventing me from drawing a right triangle? And how far is it from -3 to 5? 8 units. -9 to 1. 10 units. Do I think I can find the distance of that dotted line? I think it's the square root of 64. 64 and 100 square root, right? So that's 164 units of area. And this is a square root. I guess I can find the distance between 2 points easily. So let me give you a couple others. How about I give you 0, 0 to 5, 2. 0, 0 to 5, 2. Just because I want this video to be over. All right, so where's 0, 0? Here, where's 5, 2? Right here. How do I get from 0 to 5? Change to 5. How do I get from a height of 0 to 2? Up 2. What's that distance? Square root of 29. All right, so I'm going to stop there. That's 10 problems. I'm going to do another video, the next 10. And then I think it's all repetition on the, well, pretty much. There's a couple of things that I got to go over. So anything that's new,
In the next video, I will do, but not as often as the ones I've done here. So that'll be a shorter video, but we'll still get some good practice, hopefully. Oh, I do have to explain exponentials on this sheet. That's going to be in class. All right. And then I'll put the brakes on for a while because I'm sure you're all panicking. Okay, see you in class.